All right, stand up. Push your hand through the air. Feel that resistance. Tiny, almost nothing. Now push your hand through water. Much harder, right? You feel the drag immediately. You see, we use this as an analogy for light moving through water, but the truth is, light isn't slowing down the way your hand does. That's backwards. Now here's the thing. When we say light slows down in water, people imagine it like it's a little guy walking through molasses. But light doesn't have legs. Light doesn't get tired. Light is a wave, a vibrating electric and magnetic field. So how can a wave get slowed down? That's where it gets interesting. Let me show you. Think of light as a crowd of people marching down a street. Empty street, no one in the way, everyone moves at top speed. Now imagine the street crowded with street performers, dancers, kids jumping rope. Each time a person tries to march, they bump, they pause, they interact. Their progress seems slower. But are they really moving slower between the bumps? Nope. They are still moving at the same speed between interactions. The delay comes from the interactions themselves. That's exactly what happens to photons in water. I want you to picture a photon, a particle of light zipping through vacuum at 186,000 miles per second. It hits water. Water is full of atoms, hydrogen, oxygen, buzzing electrons. Every time the photon comes near an electron, it jiggles the electron, and the electron radiates a new electromagnetic wave. This re-radiation takes a tiny bit of time. Tiny. But over trillions of photons, these delays add up. The wavefront appears to move slower. Not because the photon itself slowed down between atoms. Oh no, that's a classic misconception. It's the cumulative effect of all these tiny interactions. Now wait. Here's what really messes with people's intuition. You think if light slows down in water, why doesn't it lose energy? Wrong question. Speed and energy are not the same for light in this context. A photon maintains its energy, the same frequency, same color, but the effective speed of the wavefront changes because of those delays. That's why a pencil looks bent in a glass of water. It's not the pencil that's bending. It's the light's path being subtly delayed at each atomic interaction. And see what's happening. This is where the classical physics picture fails. Newton imagined light as little particles like tiny cannonballs, hitting water and getting slowed. That's backward. That picture gives the right numerical answer sometimes, but it's a lie. The truth comes from James Clerk Maxwell and the equations of electromagnetism. Light is an electromagnetic wave, and the water is a medium that responds to that wave. It stores a tiny bit of energy and releases it back, creating interference patterns that shift the phase of the wave. That phase shift, that's what we measure as slower speed. Let me show you another way to see it. Ever play the game Wave in a stadium? One person stands, raises their arm, sits down. Next person does the same. The wave moves around the stadium. Nobody is actually running, but the wave propagates. That's exactly like light in a medium. The photons are like the people. They aren't running slower, but the wave of energy moves slower because it's passed from person to person. Now that is counterintuitive. You're thinking speed equals motion. Nope. Speed equals collective propagation of interaction. You want to know the truth? Light slows in water not because it's lazy, not because it's resisting, but because of quantum mechanics. Each photon interacts with electrons, and those interactions create a tiny lag. The wave emerges slower. This is the brilliance of physics. What we see macroscopically as speed is an emergent property of countless microscopic events. That's why the refractive index of water is 1.33. It's a measure of cumulative delays per unit distance. Let me tell you something that's really fun. In vacuum, nothing can beat 186,000 miles per second. But in a medium, light's phase velocity slows. Now comes the part that will bother you. The photons themselves always travel locally at c between interactions. They never break the speed limit. The apparent slowdown is an emergent effect. That means your intuition about slower light is completely backwards. Photons are still lightning fast between electrons. The medium is just tricking your eyes. Isn't that beautiful? Isn't that something? Now watch this. I can make light slow even more by using something called electromagnetically induced transparency. Scientists in Boulder, Colorado have made light crawl at 38 miles per hour. That's like a human sprint in the middle of the Atlantic. The photons are interacting with atoms in a carefully prepared gas, delays piling up like traffic jams. And when they turn off the trick, the photons shoot off at full speed. Crazy, huh? We're bending the effective speed of light without touching the photons themselves. That's not magic. That's physics. Here's another weird thought. If you look at ice, water, glass, diamond, they all have different refractive indices. Light slows differently in each. Diamond, N equals 2.42. That's more than twice as slow as in vacuum. Yet every photon is still moving at c between atoms. The slowdown is purely an emergent collective effect. It's a macroscopic illusion made by microscopic realities. Let me give you a little historical context. Newton thought light was particles. Huygens thought light was waves. Both got some things right. Maxwell tied it together with electromagnetism. Then quantum mechanics showed us photons and interactions with electrons. Feynman diagrams. They let us calculate probabilities of every interaction. It's all there, staring you in the face. What's amazing is how often we ignore the micro details and just say light slows down. That's sloppy thinking. I hate sloppy thinking. Now this is where it gets really interesting. Cherenkov radiation, ever see that blue glow in nuclear reactors? That happens when charged particles move faster than light does in water. Faster than light in water? Wait, isn't that impossible? Nope. The particle is faster than the effective speed of the wavefront in the medium. The photons themselves aren't breaking C. The medium just allows this weird supersonic effect. You can actually see it glowing blue. That's not an explanation. That's a spectacular confirmation. See what's happening here? Light's behavior in a medium is a dance between photons and electrons, a symphony of quantum interactions. The wave slows, bends, refracts, creates rainbows, but locally the laws of physics never break. That's why physics is so elegant. The paradox is only apparent. Now imagine standing on the beach. Sunlight hits the water. That sparkle you see. Those rays are refracted, scattered, delayed. Every photon playing its tiny part in this microscopic dance. The world you see is literally made of these interactions. And the light that illuminates you is weaving through countless atomic delays. You're literally bathing in the symphony of electromagnetic interactions. Isn't that beautiful? And here's the final twist. If we treat light like a particle and ignore waves, we miss refraction. If we treat it like a wave and ignore particles, we miss photons, quantum effects, Cherenkov radiation. The universe doesn't care about our categories, it just does both. And that's the beauty of it. Understanding light requires embracing the paradox. So next time you see a straw bent in a glass of water, or diamonds sparkling, or sunlight glinting off waves, remember this: the photons themselves are never slowing down. What you see as slow is the emergent property of 1,000 million trillion interactions. And you standing there are witnessing the collective behavior of quantum mechanics at work. That's a damn good question, isn't it? How can something so fast appear slow? Quantum mechanics says, because reality is subtle and your senses are simple. And that's the beautiful part. Light moving through water isn't just a physical phenomenon. It's a window into the microscopic choreography of the universe. You're made of atoms. Light dances around atoms. Everything you see, feel, touch, mediated by these interactions. And you want to know the truth? That's not abstract. That's happening to you right now, every second of your life. Key mind blow moment. Light in water isn't slower because photons lose speed. It appears slower because trillions of photon-electron interactions create a collective delay, making your reality itself a quantum illusion.